Hello, hello, good morning everybody. In today's experiment, I am going to show you impressed power system ICCP. So impressed current cathode protection system. And how earlier I have shown you that sacrificial error system and the corrosion mechanism. So I have made this setup like this. You can see this diagram. Uh, just I can show you that this diagram shows you that how we are making the connection. It's very simple as you know that in the ICCP system. Okay. So we have taken a say steel rod or a steel plate. Of course, it is a bit rugged, means it's a bare steel. Okay. And I have taken a zinc actually anode. At present I don't have MMO anode, so I am using a zinc as a say impressed current anode. So this is not a say you can say the inert material. It has a negative potential which we will measure, and so this can also be used just for your experimentation purpose. What happens when you use the ICCP anode? So the power source, I have taken a manual power source. This is the manual power source, and the positive terminal we have connected to the zinc anode, and the negative to the pipe through a switch and an ammeter to measure the CP current. So first we will measure the open circuit potential or the corrosion potential of the anode, zinc anode, before we put the power supply on. So what is your potential? That this is the say anode which we have taken a zinc anode. So its potential is say 0.80. 0.80 is the say potential because it is the bare electric anode. 0.80 and positive means that it's a connection I have done that reference cell to the reference cell to positive and this anode to the negative. So positive sign means that our quality is correct. That is zinc anode is negative with respect to the anode, with respect to the earth. Okay, so you can call it, we call it say zinc anode to your soil potential, that is minus 0.80. And what is your the steel potential? That also I can measure. The steel potential is 0.44. 0.44 is a bit less because you know that 0.45 to 0.55. So this is having a high resistivity soil and a bare rubber plate, so it is 0.44. That is number also. Now we will put the power supply source on and let us see what happens after we put an impressed current system. So as I have told you, this is the power source and I have put it on. Okay, and this is a switch, so I put it on. Now it is power source in the circuit. So slowly I will increase the potential of this power source, that is we are using the potential current. So I give it I am increasing it slowly and manually. This is the manual mode. So I increase it to say 2 volt. Now 2 volt, I have put it manually 2 volt. Here very small current, so it is not showing current. So but the ammeter is there in series. We can measure the CP current. So the CP current we put it to this multimeter and we check. That is current coming around 0.35 milliampere. Very small amount of current because it is a small plate. And this is positive, means that the current is flowing through this circuit from the steel. This is the steel plate. This is the steel plate. So from the steel plate to the zinc, that is the in the through the TR positive to negative, it is flowing, and back to your anode bed. Okay. Now we measure at this potential and 0.35 milliampere what is your potential? How much increase in the potential of the steel plate? So again we measure that potential, and we see that the potential is coming around, okay, it is 1.32, 1.32, okay. So 1.3, now 0.44 to 1.3, this is your on potential. And what is the potential of the anode? This has become minus 0.65, okay. So it has reduced, okay. Earlier it was, no, sorry, yeah, minus 0.80 to minus 0.65. So it has reduced, but now the potential is the action is a negative sign. That is, now it has become, it is being polarized, okay. It's a positive side, it is increasing, okay. It has become now minus. Earlier it was negative, now it's positive. So it is moving towards the positive side, that it anode is being polarized. So what is the off potential? Immediately now we have to see whether at this potential we have increased that, say what is the off potential? That should be either 850 millivolt or it should be 100 millivolt polarization shift. Here, since your 0.44 is your potential, hence it is difficult to get, say, 400 millivolt potential shift, that is 850 millivolt. So 100 millivolt shift also you get, that will be sufficient. So we can measure the off potential by, say we'll check the off potential, okay. So we will have to interrupt it, only that switch, this is the switch. So we have to off it, and then we have to check what is its off potential, okay. So now it is 1.34, so we make it off, and immediate potential I get 0.70. I cannot show you here, but the meter is there, okay. Or you can see it here also. If you can see it, this is there, and so now we have to touch it actually, so you can see, but you have to believe me. So now you can see that this, now it is further depolarized, so it is 0.50. So the immediate potential was 0.50. If you take the decay potential, it is 0.45. So 700 millivolt to 0.45. How much it is? It is 250 millivolt. So 250 millivolt is your drop from off potential to your decay potential or your corrosion potential. It means you are able to achieve 100 millivolt potential shift. Okay. So your line is getting polarized at your 2 volt. Okay. So you can increase further and you can see how much you get that, okay, because even then you are getting that 100 millivolt potential shift, okay. So again I am going to increase the potential. So I have manually increased the potential to 3 volt, okay, 3 volt DC output, and the current that is, again I put it on. Now current is, say, 0.50 milliampere. Current is 0.50 milliampere. Okay. So at this 0.50 milliampere, what is your potential of the pipe? That is 1.80. Now it has become 1.35 to 1.80. Further it has increased. And what is the potential of this one? Now further it has increased to minus 1.25. Now again in the negative direction. Okay. So actually it has become now, say, the positive, and it is further polarized. Okay. the fast polarization is there, so it will not last for long. Okay. So see, mind it, if you take more current, then that is a say there is a that zinc may polarize that thing and passivation may take place. It may not give to a certain limit, it will not give the current. Okay. So now you have to check what is the potential of potential. Okay. So again we see that 1.77 of it becomes 1.05. Okay, so no need to go for, of course here you are meeting the 850 millivolt potential also when you increase the potential. Okay, so from my point of view, even if you are getting a 100 millivolt potential shift, so at the 1.3 volt 2 volt input you are getting 100 millivolt potential shift. So that is sufficient for that. So that way you can say how impressed current anode system can be used for cathodic protection of the steel. And here only one thing happens, that your anode gets polarized, it moves in the little bit in the positive direction anode, that is okay, but don't put it more load on the anode. So that is why your anode output current is say sufficient. If you are not able to get say 850 millivolt, even 100 millivolt potential shift, in case of say high soil resistivity or the coating defect, in case of say your steel, if it is corroded, coating damage is there, then even 100 millivolt potential shift will be okay. So this is the today's experiment, and the next experiment we will do next time on the interference. I will take the two readings, two metals, and I will show how the interference takes place and how you can mitigate it. Thank you for listening and understanding about this impressed current system. If you have any query when I post the video, you can put the question on the video. I will try to resolve the issue. Thank you very much.